Design Analysis and Topology Optimization of Passenger Car Disc Brake Anjali Ashok Shinde, 1. Me, Design, Mechanical Engineering JSBMs, RS College of Engineering, Pune, Maharashtra. Abstract: the disc brake may be a device for slowing or stopping the rotation of a wheel. Generally, repetitive braking system of the automobile cars results in heat generation during each braking event. The brake disc brake 3D model prepared by CATIA software. Finite element modal analysis of automobile four-wheeler disc brake is performed to determine mode shapes and natural frequencies, and also static analysis is performed to obtain optimized model from topology optimization technique from ANSYS 19 software. Hence, experimental testing using FFT analyzer technique, impact hammer and accelerometer, is performed to determine mode shapes and natural frequency and comparison of results with numerical results. Keyword: disc brake, topology optimization, FFT analyzer. Introduction. The racing fans involved will surely know the importance of good brakes, not just for safety but also for staying competitive. The disc brake may be a device for slowing or stopping the rotation of a wheel. A brake disc, usually made from forged iron or ceramic composites, includes carbon, Kevlar, and silica, is connected to the wheel and therefore the axle, to prevent the wheel. A friction brake generates frictional forces as two or more surfaces rub against one another, to scale back movement. Based on the planning configurations, vehicle friction brakes are often grouped into drum and disc brakes. The main component of the braking system is the disc brake. Its performance directly affects the driving safety of the vehicle. When the vehicle is braking, the excitation frequency is close to the natural frequency of the brake disc, which will cause resonance, generate severe vibration and noise, and affect ride comfort. Therefore, it is necessary to analyze modal characteristics of disc brake. Tata Sumo 800 laser car disc brake was taken for experimental study purpose. The brake disc, or rotor, is the rotating a part of a wheel's disc brake assembly, against which the restraint are applied. The material is usually grey iron, a sort of forged iron. The weight and power of the vehicle determines the necessity for ventilated discs. 2. Problem statement. Nowadays, topology optimization technique is used for weight optimization of components, which reduces material cost and manufacturing. In present research, four-wheeler disc brake is to be studied under FIA to determine the optimum material removal from existing four-wheeler disc brake under existing boundary condition, and also determine changes in von Mises stress and deformation with tautologized model. Natural frequencies are calculated to determine the nature of mode shapes at respective frequencies. 3. Methodology. The methodology involves the technology utilized for performing the designing and analysis of the object. Design of four-wheeler disc brake. Dimension specification. Analysis of disc brake by ANSYS. Static structural analysis and modal analysis for mode shape. To perform static structural analysis of disc brake under existing boundary condition to obtain deformation and von Mises stress and optimized model from topology optimization. The best optimized is to be obtained from topology optimization technique and compared to the existing model. 4. CAD design. Design parameters of Tata Sumo 800 laser car. Disc diameter equals 260 mm. Disc material equals grey cast iron. Disc thickness equals 12 mm. Internal diameter equals 140 mm. Internal thickness equals 50 mm. Hole diameter equals 10 mm 5 holes. Pad brake material equals asbestos. Pad dimension equals 125 mm x 12 mm. Used CATIA software. CATIA is mechanical design software. CATIA users access the highest productivity for specific advanced processes with focused solutions. Sketcher. Part design. Assembly design. Wireframe and surface design. Drafting. Analysis of disc brake in CATIA. Meshing structural static and modal analysis by ANSYS software. V-design calculation. Input parameter for disc brake of Tata Sumo 800 laser. Parameter name. Parameter value, unit. Mass of vehicle. 2625 kilograms. Speed of vehicle. 100 km per hour equals 27.7 m/s. Wheel diameter. 600 mm. Wheelbase. 2425 mm. Table 1, Basic parameter of vehicle. Parameter name. Gray cast iron. Density. 7000 kg/m3. Yield tensile strength. 142 MPa. Young modulus E. 100 GPa. Poisson ratio. 0.28. Specific heat, Cp. 586 J/kg.K. Thermal conductivity K. 54 W/m.K. Table 2, Properties of gray cast iron. Parameter name. Parameter value. Outer diameter of disc. 260 mm. Inner diameter of disc. 140 mm. Hole diameter. 10 mm. Thickness of disc. 12 mm. Weight of disc. 6.2 kg. 6-dot analysis. Tata Sumo 800 laser car disc brake is taken for analysis. After designing disc brake rotors in CATIA V5, the profiles is imported to ANSYS workbench for further analysis such as static structural analysis, and modal analysis. Material selection for disc brake gray cast iron. Fig.5 Engineering material properties in ANSYS. Geometry of existing disc brake. Fig 6 Geometry of disc brake imported in ANSYS. Meshing. Meshing done by ANSYS software to reduce degree of freedom from infinite to finite with the help of discretization or meshing, nodes and elements. Fig 7 Details of meshing. Boundary conditions. Fig 8, Boundary conditions for disc brake MA. Disc brake is fixed at one end to determine the mode shape and natural frequency. Modal analysis. Modal analysis may be a technique to review the dynamic characteristics of a structure under vibrational excitation. Natural frequencies, mode shapes and mode vectors of a structure may be determined using modal analysis. Different mode shapes. The modal frequencies of the first 5 steps and modal shapes of each order shown in below figures. In above figures, different mode shapes are plotted with respective natural frequency, so it is observed the mode shape pattern also change with respective frequency, so maximum frequency is observed around 1446 N. Static structural analysis. In above analytical calculation, A. Pressure acting on pad is calculated as 2.29 MPa, but design is for maximum conditions, so standard equation to calculate pressure on pad is given below. From paper mentioned standard equation is so. Pressure on rubber pad is 4 MPa on both sides are applied. So, we have 4 MPa and 2.29 MPa as per design. It is beneficial to use 4 MPa as design should sustain extreme pressure due to fluctuation of motion on disc brake. Boundary condition. In boundary condition following are forces, pressure is mentioned. Fixed support is applied along circular bolt holes and across edges as per existing situation. Pressure of 4 MPa as per calculated analytically is applied on both surface of caliper pad as shown in red region. Rotational velocity of 170 rad/s equals 80 km per hour is applied indicated in yellow region. Total deformation results. Fig.11 Total deformation results. It is observed that maximum deformation is 0.0108 mm. Equivalent stress results. Fig 12 Equivalent stress results. Maximum stress observed is 16 MPa. 7. Topology optimization. Topology optimization could also be a mathematical approach that optimizes material layout within a given design area, for a given set of loads and boundary conditions such the resulting layout meets a prescribed set of performance targets. Basic theory. There are 3 types of structure optimization. Size optimization. Shape optimization. Topology optimization. 3 optimization ways in which correspond to the 3 stages of the merchandise design methodology, significantly the detailed design, basic design, and conceptual design. Size optimization keeps the structural form and topology structure invariant, to optimize the varied parameters of structure, like thickness, section size of beam, materials properties. Shape optimization maintains the topology structure, to vary the boundary of structure and form, explore for the foremost applicable structure boundary scenario and shape. Topology optimization is to hunt out the foremost effective path of materials distribution throughout never-ending domain that meet the displacement and stress conditions in structure, produce a specific performance optimum. Thus, compared to size and shape optimization, topology optimization with more freedom degree and bigger design area, its greatest feature is below unsure structural form, keep with the well-known condition in a given load to work out a budget structure, every for the abstract sort of recent product and improvement design for existing product, it is the foremost promising side of structural optimization. For continuous structure topology optimization, there are some mature ways like uniform technique, evolutionary structural optimization technique, variable density technique, etc. Uniform technique introduced cell structure of microstructure, unit cell, at intervals the weather of the structure, each unit has 3 forms, significantly non-material voids, size equals 1, isotropic material entity medium, size equals 0, and orthotropic material opening hole medium, 0 size 1. Whereby the distribution of every form are able to describe the shape of topology and conjointly the shape of structure. Evolutionary structural optimization technique believe that stress in any elements of the structure should beneath the identical level in a perfect structure, thus you will be able to delete the fabric artificially. Thus bit by bit remove material that in a very low stress state, then delete the update rate, thus optimized structure becomes more uniform. Variable density technique is employed to conduct optimization throughout this paper. Fig. 13 Process of topology optimization. Boundary condition. Fig. 14 Boundary conditions for topology optimization. In boundary condition of topology optimization, exclusion region are boundary condition applied in static structural analysis, these are excluded. Equivalent stress. Fig. 15 Topology optimization results. 8. Experimental testing. The experimental validation operation is finished by using FFT. Operation testing, fast Fourier transform, analyzer. The FFT spectrum analyzer samples the input, computes the magnitude of its sine and cosine components, and displays the spectrum of these measured frequency components. The advantage of this system is its speed. Because system operation FFT spectrum analyzers measure all frequency components at identical time, the technique offers the likelihood of being persistently faster than traditional analog spectrum analyzers. This analysis will be expressed as a series operation. The fast Fourier transform could be a method of operation, mathematical method for transforming a function of your time into a function of frequency. Sometimes it's described as system transforming from the time domain to the frequency domain. It's very useful for all method analysis of time-dependent FFT analysis. FFT is one main property in any sequence getting used generally. To find this property of FFT for any given sequence, many transforms are being employed. The most important issues to be noticed find this property are the time and memory management. Comparison is finished between the 2 algorithms with relevance the memory and time managements, and therefore the better one is pointed. Comparison is between the 2 algorithms written, considering the time and memory because the sole main constraints. Time taken by the 2 transforms find the basic frequency is taken. At the identical time the memory consumed while using the 2 algorithms is additionally checked. Supported these aspects, it's decided which algorithm is to be used for better results. 9. Summary. Modal analysis of hydraulic brake is performed to get different mode shapes and natural frequency of existing 4-wheeler hydraulic brake. Static structural analysis of hydraulic brake is performed to see deformation and equivalent stress. Its observed around maximum deformation is 0.0108 mm and equivalent stress is 16.76 MPa. It's concluded that the region indicated in the pit in topology optimization provides information regarding removal of material from that area. It's about 55.53% to original mass.